So in this table, you're going to look for the substance given. Okay. So we're talking about sodium nitrate, which is this one right here, and it corresponds to the graphing, to the linear graph, which is in color, in blue color. Okay, it's this one right here. Okay, so all you have to make is look at the temperature. The temperature given in the problem is 10 Celsius. So we're going to look for 10 Celsius right here. Take a look, the temperature over there is in Celsius. So you're going to locate the temperature of 10 degrees Celsius, and you're going to follow until you reach the, the graph for sodium nitrate. So according to this, the solubility of sodium nitrate is 80. Okay, so at 10 Celsius degrees, solubility is 80. Okay, and in the case of potassium nitrate, they are telling you that it is at 60 degrees Celsius. So you have to do the same procedure in the here in the table. Okay, look for potassium nitrate. In what color is potassium nitrate in the table? In what color you find potassium nitrate in a table?
Yellow.
In yellow. So it's this one right here, right? Because it's yellow. It's this graph over there, okay? So once that you have located the potassium nitrate, look for the temperature. The temperature is 60 degrees Celsius. So 60 degrees Celsius is located right here. So you will follow, okay, the line until you reach the graph. And then you will do the same procedure here. Well, it doesn't say specifically if it is 100 degrees, right? Let's take a look. It's more than 100 because 100 is here, and it's less than 110. So we could say that it is approximately equal to 105. So the solubility here is approximately equal to 105. So that's what you have to do with that kind of exercise. Now about the other one, let me see because I didn't read the other question. What quantity in grams of methanol is required to prepare a 0.244 molar solution in 400 grams of water? Okay? So because we are talking about molar concentration, it means that we need to use the equation for molality. So that's going to be the first step. And the first step is written here in the problem. We have to rearrange the equation for molality in order to find the number of moles. So this is going to be the first step. So we know that molality is equal to number of moles of solid divided by kilograms of solvent. Now, take a look here. I haven't identified the solute and the solvent, but we can do it right now. In this exercise, as I told you before, we have methanol and we have water. We need to identify the solute and the solvent. The solute is the substance that is going to be dissolved. So what substance is the solute here? Or easier, even easier, what substance is
Metal.
The water is the solvent or the solute?
Solvent.
The solvent, and as you, my friend Ashley said, methanol is the solvent. Okay. So that is the first step that we do. We identify the solute and the solvent. And then we need to make sure that we have everything that we need. Okay? The problem gives us molar concentration. It gives us grams of water, which is the solvent, but the equation tells you that the solvent must be in kilograms. The first step will be converting from grams to kilograms. Okay, so I'm going to do this conversion process right now. 400 grams, I will convert to kilograms, okay, by using the conversion factor of 1,000 grams per kilogram. Allows me to cancel grams with grams, and this gives me 0.40 kilograms. That is going to be the first step. Now, it says rearrange the equation for molality. In your book, it appears molarity, but it's not involved in the equation, okay? Because the problem tells you about molar concentration. Main difference, this is molarity, and this is molality, okay? It's different. So the problem gives you molality, which means that is the equation that you have to use. Now, to get the number of moles, I already gave you the isolation, but you have to look for the number of moles by using this isolation. Number of moles of solute, okay? This one is doing a division, so when you move it to the other side, it's going to be making a multiplication. So this will be molar concentration times the kilograms of solvent. That is the equation. And now it says, substitute the given information into your equation to find the number of moles of methanol. Not hydrochloric acid, it's methanol, okay? The book, it had a mistake, okay? So, we use the given information in the problem, which is the molar concentration, that is 0.244 molar, and the kilograms of solvent, that is 0.40 kilograms of water. How much is this?
0.0976.
0.0976. So I'm going to round it, okay, to 0.10 moles of methanol. You said that it was, let me see, it was 0.0975, right? So we round it, okay? Approximately equal to 0.10. So this is the number of moles that you are looking for. And then it says, the problem says, what is the molar mass of methanol? So methanol has a formula that is given in the problem, and it is CH3OH. CH3OH. Okay? So the molar mass is 1 carbon, 4 hydrogens, because you have hydrogen, 3 hydrogens here and 1 over there makes 4. And you have 1 oxygen. So the molar mass is 1 times 12 grams, 4 times 1 gram, and 1 times 16 grams, which gives me 12 grams plus 4 grams plus 16 grams. In total, I have a molar mass of 32 grams over mole. This is the molar mass of methanol. Okay? And in the last part, it says, what is the mass in gram of that number of moles of methanol? So remember, the number of moles we got 0.10. So we're going to start 0.10 mole of methanol, CH3OH. Okay? And I need to get the number of mass, the mass in grams. I will use my molar mass as a conversion factor. So I say, in 1 mole of methanol, I have a molar mass of 32 grams of methanol. This allows me to cancel moles of methanol with moles of methanol, and this gives you 3.2 grams of methanol. So from the beginning, you have like to make a few corrections, okay? One of the corrections is that instead of molarity, like the problem says, you have to write molality instead. And here, when it says substitute the given information, is to find the number of moles, not from hydrochloric acid, but for methanol. Okay? Once you do those corrections, you can do the exercise as you are used.